We have a MacBook Air. It's an A1466, 13 inches. Because of the JTAG connector here, we see we have a small JTAG connector. So this is either a 2015 or 2017, given the JTAG connector. So by design, this can only be a 2015 or 2017 mainboard. So the description says it's a no power. However, what we found was after we took out the back cover, we actually found that the device actually powers on, but it doesn't post. Just hit the power button. Okay, that's a new development. So previously when we connected the charger, so because the client said that they wanted us to first give them a price tag, and also they wanted to have an idea of exactly what is wrong with the device. So we were not supposed to go ahead and do repair. So when we did connect power to it at first, we could get the fan would spin, but there was no posting taking place. But right now we see that the device is not even posting, the fan is not even spinning at all. Okay, so let's just quickly go ahead and but just some let's confirm something. Let us see if the device is in SO state. So this is an 80-00165. Just open that up. 80-00165 here. Okay. Okay, so this is the board view. Let's see if the device is in SO state. So we can confirm from L7520, 5 volt here will indicate that the device is partially making its way into SO. So which would mean that the device is partially on, but due to a failure in one of the required region, and then the device is not working as it should. So let's see if we have 5 volt on our inductor here. Uh, Wait, I think I got 5 volt and then okay, so that's a so we actually getting a pause. So it's like a quick um, yeah. So there's a pause on, so which means the device is trying to make its way into SO, but some reason something is preventing it from doing so. So let's quickly take the board out and flip to the other side of the board to see. Most likely this will be an issue of oxidation or corrosion in a particular region. So let's quickly take the board out and see which region on the other side of the board is our problem. To take the screws on the board out, you only need a T5, and the back screws you need a P5 for it. Okay, so usually I wouldn't take out the DC jack because I will utilize a test DC jack for that purpose. I would not take the DC jack out. Usually I don't take the DC jack out unless if there is a particular reason to do so. For example, in a case of liquid damage, then in that case, the DC jack will go out, not because I need to use it, but because obviously because if we need to replace it. Okay, the board is out. Let's put the shell on the side. Okay, so as we can see, that's clearly what it is here. So so you see this region here, so that is definitely where our problem lies. So let's try to dust the board. And this is a 2017, and two ways that you can easily tell that it's a 1.8, and then also the type of image processor that's used, which is the webcam. So on the 2015, usually the 2015 we use, I'm just gonna get another board to show you guys a similitude. So if this was a 2015 board, usually what will happen is the image processor here will look like this and not like this. So for 2017, usually this would be the choice of chipset that is utilized on the 2017 MacBook Airs. Okay, so we have an issue in this section of the board. Uh, hmm, okay, that doesn't look good. Let's see, what is that? So it's this region here. So we have C1212. So we have C1212 being affected. We have C1208 being affected. We have R6110 being affected. We have okay. So that's gonna be yeah, SPI ROM chip. It will have a role to play on the SPI ROM chip region. Let's see, so this I believe is affected, and this affected, this affected, this affected, and then that affected. Okay, so let's start by checking if we have, if this C1212 is creating a short on the board. Let's measure for short real quick. You can measure for a short here. Okay, no, we are not, there's no short on our SO line, but definitely C1212 has to go because it's not looking good. So what we are going to do is we're basically going to try to work around all of those components. Will have to go, and then we'll replace them, and then we hope that solves our problem. Hmm. Okay, all of the components are out. The next thing we want to the ones that are affected are out. The next thing we want to do is clean that region. The cutting board's finished. I think I saw one somewhere. Um, okay, this one here. We hope we still can find the pads. It's important we get the pads because without the pads, there will be no communication line generated. Okay, I need to try to get the pads. Let's get a donor board. Hmm. So we are going to do the replacement according to how important the components are, according to the role they play. So first thing first we want to focus on is getting the device to power on, and then we can address the other issue. So, so okay, so let's see what is most important. Let's start by the roles they play. So R6110, that definitely needs to be addressed. Let's say R5110 is okay, and then okay, so R5110 as well as R1548 that needs to be addressed. Afterwards, we can come back to R1625 and R1341, also R1618 and R1681. That we are not going to worry about. So for now, we're just going to worry about this and this. Okay. Okay. So first and first, let us replace 6110 and 1548. Actually, before we do that, now that we have enough room to apply solder in the pads, let's completely apply solder in all of the pads before we start to replace the components, so that we don't struggle after some of some of the. Okay. Like I said, first and first, we want to focus on how important the components are. First, get the board to power on, and then we can work on the others. Actually, we can just go ahead and replace them now instead of yeah. Let's just go ahead and replace them now. And then what else? We need two. Yeah. And then cap here that needs to be replaced. Okay, and then we have two caps to go, though the caps are not um, they're not that relevant. So which is talking about to get the board to power on, even without the caps, this particular caps, the board will still power on. Okay, so that's done. So I'm not gonna. Before we test it, I'm going to go pray now. When I come back, we can do the test because I believe it's time for prayers. So when I come back, we can do the test and continue from there. Now we want to test to see if we have any changes. Hopefully, we does. Wait, that's not the DC jack. It is. That's a Maxif 1 2010 2011 DC jack. Okay. Do we have a fan spin? Okay, we have a fan spin, which is good. The next thing we want to confirm is do we have a posting board? Let's see, from the fan we can tell. Okay, from the switch of the fan from high to low, from low to high, that is indicative of the device. That's the point of the post of the device. The point of basically switching to a post mode of the device. So from the behavior I saw from the fan, I can tell that the device is posting, but then again, in order for us to fully confirm that, let's plug a screen to it. This is a test screen. It's broken, but it would serve the purpose. Okay, screen is connected. We have fan spin. Okay, should expecting it to post now. We're not getting anything. Let's see, do we have voltage to our screen? Say if we have voltage to the screen. Now we don't. So which means okay. So let's try the board in its shell. I'm only going to connect the cables that I need for the purpose of the testing. Speaker connected because I would like to get a chime sound. IO board connected because without that I will not be able to get a chime. I also have the keyboard connected because I would like to see if I have a caps lock. Okay, we have fan spin. We have a chime. Now we don't. Let's try up here on this side. I'm not really optimistic about a pyramid set doing making any changes, but let's see. Okay, so the device is still not posting, but we definitely do have power to the board now, but we are not posting. So this is basically it's almost like so by what we mean by device not posting is it's basically that the device is brain dead. Uh, let's see. Let's see. Look at the fan behavior. And also the fan is not switching. The first time we tried the board, the fan did switch. But now it's not doing that. Let's try that again. Yeah, that's different. But that's different. Let's see, do we have voltage to the screen? No, we don't. Okay, so let's go back to the area we walked on, see what we are missing. So I believe we're expecting to have 3.3 volt at pin 2 of R1548, as well as okay, we see that. So let's also see what it is that we have. I see there's also been like a previous work by the SMC. What was this? What was this? Let's see. What by what was that? Let's see. What did they do there? R5117. It's a CPU thermal chip. Okay. Nah, don't really. It's not quite relevant right now. It also seems like there was a bit of a aha. See, there's a bit of a corrosion around the SMC there. So what you want to do is you want to reflow the SMC, because that can also prevent the board from posting. So we're first going to do reflow the SMC, and then also afterwards, if we still doesn't work, we may want to go back to the area where we worked, and finally, if everything checks out on that side, then we may have to remove the SMC to see if we have any type of dirt underneath the SMC, which would prevent the because when you have accumulation of dirt under the SMC, that could prevent the board also from posting. So, and that's depending on what section of the SMC or what region of the SMC the corrosion sits. Okay. See if we have any changes. The board is still very hot. We are going to give it a bit of a, say, a minute or so for the board to cool off. So here it also looks like we have some kind of oxidation or corrosion around the SPI ROM. We are also going to check that out because yeah, so it's really a concern. So if you see the two parts there, so that's going to be pin 1 and 2 actually. So pin 1 and 2 are not looking good. So that we may have to check out as well. Let's see if we have any difference. Let's see if anything has changed, and then we then move on to the SPI ROM. Okay, we have fan spin. Is it posted? It would almost seem like it is posted, but nah, it's not posted. Because the sequence of the fan is almost indicative that the board is going into a posting mode, but that's not what's happening. Okay, so let's check that section. Let's check the section of the BIOS chip, which is the SPI ROM, because I see pin 1, the pads on pin 1 and pin 2 do not look okay. Let's check that out. We're still going to go back to the region we walked, but so we will be checking to see if we have, say, a broken via. Yeah, okay, so first things first, let's try to address what seems out of place. That's actually not the case. So even though we have that, uh, the pads for pin 1 and 2 are still in place. Yeah. Okay, let's see. Pin 1, let's check continuity. Let's see pin 2 and arrow 6112. Let's see if we have continuity. Alright, we're supposed to have continuity between pin 6123 and pin 2 of E6100. Do we not have? Yeah, okay, as expected. And then pin 1, we're supposed to have continuity between. Let's remove U6110 just so that we can get to. It's because we may not be able to get under it. Let's see. Okay, so that's fine. We have continuity across. Okay, see if we have any changes. Okay, so while to also save time, let's connect the screen, and also we will be checking out the region we walked earlier. Okay. So do we have a fan spin? Okay, we have a fan spin, and let's go over to the area we walked. See, what are we missing here? Let's start from R6110. R6110. Let's switch that to voltage mode. Okay, that's 3.3, that's expected. 3.3, that's expected. And then the other 3.3 expected. 3.3, that's expected. Let's see. What else? What else are we missing? Our 1625, not really relevant to our issue. Our 1618, not relevant to device not posting. Our 1681, not relevant to device not posting. Okay, let's see. Do we have our 1.0 volt? Yes, we do. Okay, let's try something. Let's try a different. Let's try a different SPI ROM chip. Okay. See if we have any changes. After this, we are going to take out the SMC to see if we have any curve under the SMC. Okay, uh, so that means we definitely will need another SPI ROM chip. So what we are going to quickly do is we are going to quickly program one, and so because of the ME region, so definitely we see that the problem it's the SPI ROM chip. So we are going to reprogram this because of the ME region. If we don't do that, the device is going to be very, very slow. So let's quickly program this. You already have a bias chip in here, so we'll just use that. Let's quickly program it. S65 program. And then afterwards, we'll have to serialize the board as well. Because just by doing this, the serial number will appear as unavailable. So after we finish, we'll also have to serialize the board. So let's see. This cap here is not looking good. I think it would be better to replace it now. Even though it's not directly connected to our current issue. Okay, chip is ready. Wait, this is the faulty one. This is the faulty one. So this is the one that did work, yeah? Okay, so this can just go back here. And it's important to orient the chip accordingly. Okay, let's test that again. Actually, let's try with the client screen this time. We are still going to clean the board, but right now we just want to confirm that it works. I would like to hear the chime, so that's why I'm adding the IO board cable. Okay. I have so it's like conversion and the IO board cable. We'll come to that. Okay, we'll have to get another cable just to be sure. Okay, we got a chime, and then we also have light on our screen. Okay, let's see, do we have hold on. Okay. See if our drive is detected. Drive is detected. Okay. Okay, that looks good. Device is that cable will definitely will need to be replaced. Yeah, it's misbehaving. So when you're putting together, you put in another cable. You see that? Okay. Yeah, that's about it, guys. Thank you so much. I'm just going to clean the board, and then this will now go into the next phase of assembly, and then it will get tested, and then it will go to the client. Thank you, guys. I'll see you guys in the next one.